Hi, algebra students or algebra 2 students. I'm trying a different method today for recording my video. So I'm actually using my document camera today. So you'll actually see my hand and my page as I write. So today's notes are going to be called Graphing in Standard Form. And make sure you also add that to your table of contents. Okay, so the first part of the notes is we're just going to kind of go over finding some basic characteristics of a quadratic function given the standard form of a quadratic function. And so the standard form, first of all, you should be pretty familiar with it. It's this ax squared plus bx plus c, but that's not an equation, that's not a function, right? So the idea of it being a function would be to put the f of x equals in front of it. And we get this standard form equation. Now, one quick thing to note before moving on about the standard form is that this a value right here, I'm kind of going to make a little side comment about it. This is the same a value as in vertex form. So what that means is it's doing the same types of things to our graph as the a value in vertex form. So that was the vertical stretch and shift, making it skinnier or wider. Or sorry, stretch or shrink. And the other thing that a controls is if a is negative, it's going to be a reflection. So that's a good thing to keep in mind. If a is negative, you know that your graph is going to be facing down. It's negative a. Okay, so that's just something to keep in mind, as we should have some idea of what this graph looks like just by thinking about the a value. Okay, so we're going to sketch a quick graph over in this open space right here. So I'm going to draw in a coordinate plane. And I'm just going to kind of pick a place to put a vertex. I'm going to say this is my axis of symmetry right here, going through that point. And then I'm just going to have this be a quadratic where a is 1. So if I go up, I'm going to plot the usual points, over 1, up 1, and the symmetric point. And then from here, over 1, up 3, and the symmetric point. So that's just the 1, 3, 5 rule. So now I'm going to kind of sketch this curve, the parabola. Remember to kind of curve your parabola at the bottom. Okay, so we're going to label some key points on this graph. One of the key points is going to be the vertex, obviously. Another one is the axis of symmetry, which is the dotted line. And the third important point of characteristic I'm going to kind of highlight here is where the graph is crossing the y-axis, also known as the y-intercept. And in the exploration in class today, you actually figured out that the y-intercept, which is where x equals 0, will always be the c value in standard form. So we have x is 0, but y is c. And this is because if we plug in 0 into the ax squared plus bx plus c, we're going to have a times 0 squared, that's just 0, plus b times 0, that's also just 0. So all we would be left with is the c. Okay, now the next thing I'm going to introduce to you is not something you've seen before in this class. You may remember it from Algebra 1, but there's a formula to derive the axis of symmetry, and this is a formula that you will need to memorize. It will always be x equals negative b over 2a. Okay, so if you have a quadratic function in standard form, you can always find the axis of symmetry by plugging in the b value from your equation on top and plugging in the a value on the bottom in this formula. So just a quick note, this is a formula you will need to memorize. Okay, so now remember that the axis of symmetry is running straight through the vertex. So the x value that is the axis of symmetry, that vertical line, that is also the value of x in your vertex. So if I come up here to think about how can I describe x and y in my vertex, it's no longer, I don't have an h and a k in this formula like I did in the vertex form. So I'm going to say the x value is negative b over 2a. And that's what b and a are just numbers, so we can always evaluate this and get a number. It might be a fraction, but we can always do it. And then in order to get the y value, the idea would be we take that x value and plug it in for x in our equation. So this is going to look a little weird, but I'm going to write f of negative b over 2a. And what that means is we're plugging negative b over 2a in for x in our function of f. Okay, this may look kind of strange right now, but we're going to look at an example which should make it more clear. Okay, so I'm going to scoot this up a little bit to do an example. And so all we're doing here is we're going to be given a function, f of x equals 2x squared minus 4x plus 7. So what we're going to be doing is we're going to find the vertex and the axis of symmetry. Okay, so actually the first thing I'm going to find is the axis of symmetry because that's our x value of our vertex. So I need to find that first anyways. So if I am looking to find the axis of symmetry, I'm using negative b over 2a. And in this case, if I look up here and I think about my standard form, I have ax squared plus bx plus c. Then I know in this case a is the 2 and b equals the negative 4. So make sure you take the sign in front of the coefficient as well. Okay, so plugging in I would get negative 4. So that looks like negative 4 divided by 2 times 2, because a is 2. And simplifying here, I'd get positive 4 on top divided by positive 4 on the bottom, which is just 1. So this is telling us that our axis of symmetry is x equals 1. Okay, we found the axis of symmetry. To find the vertex, we're now going to take that value of x and plug it in for y. Or plug it in for x to find y. So to write that, we can say plug in axis of symmetry for x to find the y value of the vertex. So in this case, what that's going to look like is I'm doing f of 1, because 1 is the x value that I'd like to evaluate at. So that means I'm plugging in 1 for both places where the x's appear. So I started just kind of by putting a blank spot where the x's were, and now I'm plugging in 1 there. And if I simplify this, this is going to give me 1 squared is just 1, so this becomes 1 times 2, 2. Minus 4 times 1 is 4, plus 7. This becomes negative 2 plus 7, which is negative 5, or positive 5, sorry. Okay, so now if I then am asking what is the vertex? Well, this is the y value of the vertex, and the x value is the value we already found in the axis of symmetry, the 1. So if I'm writing my vertex, I'm writing the point 1, 5. Okay? Now that we've done all this work, one other thing we can do here would be to write the quadratic in vertex form, because now we know the vertex. So the vertex form here would be f of x equals, so it's ax minus h squared plus k. Well, remember, h and k are the x and y values of your vertex. So h should be 1 and k should be 5. The a value up front should be the same a value as in standard form, so that's going to be a 2. So I'm plugging a 2 in for a. I keep x because I need an x in my formula, minus h, so minus 1 squared, and then I do plus k, plus 5 in this case. And I need a f of x equals. Okay, so to kind of practice doing this process, what I'd like you guys to do is I'll give you guys a you try problem, and it's the same problem that's going to pop up on your screen in PlayPosit, which would be to convert to vertex form, which basically means find the axis of symmetry, find the vertex, and then write it in vertex form. Convert to vertex form. F of x equals x squared plus 16x plus 5. Okay, so pause the video, or if you're watching on PlayPosit, it'll pop up and you can do that problem. Now, before I finish the notes, I do want to do one example where I show you how we can use this process to then plot points and graph. Okay, so my next example is going to be graphing in the standard form. Okay, so we're going to look at this function, f of x equals x squared plus 2x plus 3. Okay, and the first thing I'm going to do is I can find my axis of symmetry. And in this case, I'm doing x equals negative b over 2a. b is 2, so I'm going to do negative 2 over 2 times a is just 1. I don't see a number out front, it's just 1. Okay, which is exactly negative 1. Okay, so now I know my axis of symmetry is x equals negative 1. The second thing I'm going to do is find my vertex. Well, I already know the x value of my vertex is negative 1, so I can find the y value by plugging in negative 1 for x in my equation. And I get negative 1 squared is 1, minus 2, because it's 2 times negative 1, plus 3. This is going to be negative 1 plus 3, which is positive 2. Okay, now I know my vertex is the point x equals negative 1, y equals 2. Okay, so now that I have that first point in my axis of symmetry, I'm going to come here and kind of sketch a graph. And I know a is 1, so I know it's going to be facing up. So I go over to negative 1 and up to 2. There's my vertex, and I'm sketching in my axis of symmetry. Okay, from here, well, I actually have enough information to write this in vertex form, right? Vertex form here would just be x plus 2, or plus 1, sorry, because it's minus 1, squared plus 2. And a is 1, so I didn't write anything up front. So you could think about plotting more points just by plotting the usual points, right? So we can plot the usual points, but we actually have another 2 easy points that we could plot, which is also plot the y-intercept, because the y-intercept is easy to find, it's 0c. So we can plot the y-intercept and symmetric points, or point. So what that would be, in this case, if I look up at my c value, c is 3. So my y-intercept is going to be 0, 3. So I come up here, I can go over 0, up 1, 2, 3. And then the symmetric point is going reflecting it across the axis of symmetry and getting 1 more point. Okay? From here again, I could plot more points thinking about my usual points. So a is 1, which is telling me I'm plotting over 1, up 1, then up 3, then up 5, right? So from here, I already did the over 1, up 1 to get to my y-intercept. So from there, I would go over 1, up 1, 2, 3, and get another point, which I could then reflect over the axis of symmetry to get another point. And from here, I could go over 1 and up 5, but that takes me off my page. So instead, I'm just going to say, that looks like enough points. I have 5 points on my curve. That's enough. And I can sketch the curve. So we will be practicing this process in class tomorrow, and you can ask me any questions you may have then.